Okay, so as I was talking about before, that we need some sort of alternatives to adding a lot of diodes in series together to get higher levels of voltages. So how to do that actually? So one of the best alternatives is the Zener diode. So why do we use it and how do we actually use it as alternative to those series diodes? So first of all, a basic information about Zener diodes is that they are used in their reverse region, or they are basically used in their breakdown region. So first, if I want to show you the symbol of a Zener diode, here in the right side I have I have drawn the symbol of a basic Zener diode in with red pen. So here you can see that the cathode is actually pointed upwards and the anode is downwards, and we are taking the voltage from the cathode side, so we are using it in its reverse direction, and it has this special symbol to show that it is different from normal diodes, that is a Zener diode, so its symbol is a bit different from normal regular diodes. So is it something like that this Zener diode is always going to be used in reverse direction? It can never be used in forward biased, or like normal diodes, like how they are usually used in their forward biased region or like that. So no, there is no limitations like that. It can also be used in its forward biased region, but it's just that for voltage regulation we use it in its reverse region. And why is that? I am going to explain it. So first of all, if I look at the IV curve of a Zener diode, well, here I have drawn a normal IV curve. I have not pointed out all the basic parameters. I have just drawn the basic IV characteristics to give you a little bit of idea about why we use this Zener diode instead of adding a lot of diodes in series. So first of all, if you look at the positive side, you can see that the graph is just like any typical diode, and it has a slope of 1 by a small rd. That is the equivalent, the small rd is the equivalent resistance of this Zener diode for forward bias, like all those normal diodes or typical regular diodes in its forward bias region. And you can actually see that this slope of the positive side is actually quite smaller than the slope in the negative side, in the reverse region. You can see that the reverse region is almost like a line parallel to the y-axis after a certain point. It has a curvature, say at the instance Vz naught that I have pointed out, and after that just a few millivolts after that, it becomes almost like a straight line which is parallel to the y-axis, and so its slope is actually quite high. So, and normally its slope is just like any other diode, it's just 1 by a small rz. So why have I written a small rz? Because this resistance is for the breakdown region or for the reverse region, and that rd resistance was for the forward bias region, and these two are different. And obviously these two are different because these two curves have different curvatures and different slopes. So as I was talking about the reverse region, its slope is quite high. It's almost a parallel line to y-axis. So as the slope is high, slope is 1 by rz. So as the slope is high, so rz, 1 by rz is quite high. So rz must be pretty small. So this rz, so as this rz is pretty small, so that regulation part, that slope part of our regulators of that a small r divided by a small r plus capital R. This small r part is this small rz part. This is actually getting quite smaller, so that slope part is getting decreased. And what about that a lot of diodes in series together? So why are we using this single diode instead of a lot of diodes? So one of the reasons is that, well, yes, this resistance has been decreased, but can it provide me any number of voltages, any value of voltages? So yes, it can. So I do not need to add a lot of diodes in series together to get like a 2.1 volt or 3.5 volt or 4.5 volt, so on. I can normally get, by using Zener diodes, from a few volts to a few hundred volts, because this Zener diode can provide me that voltage, that VZ can be actually in the range of few volts to few hundred volts. So I can get it with the use of a single Zener diode, and its resistance is also very small. So this is a wonderful alternative to that series of diodes. And now if I want to talk about the basic IV characteristics of this Zener diode in the reverse region, see, here there are certain points. There is this VZK point that I have pointed out, VZK and IZK. Then there is this VZ0. Then there is this VZ, and also there is this IZT, this del I, this slope, and also I have written some terms, knee current, knee voltage. So we are going to talk about all of this in our next lecture.